Hello. I wanted to show you how to add vectors using, using graphical techniques. So what this actually involves, and this is part of the next lab, the vector lab, is determining the angle at which you're going to draw a vector and then drawing it to the proper length. So I'm going to do that for 3 vectors. I'm going to effectively add them together and show you can do this all graphically, which is part of what you're going to do in the lab. And I'll explain that more in the lab, and if some of you don't have a protractor. I happen to have some protractors here. Here's one. Usually they come much smaller. They're ones you can use by hand. And if you don't have one, I will get you one that you can print out that you could then use for doing this kind of work. All right, so I'm going to show you here. The first step is to construct an angle that is 200 units. Now what's a unit? A unit is whatever you want it to be. I could make it to be millimeters. So 200 millimeters would be 20 centimeters, which is something I could easily measure on my board. You could choose a unit to be an inch, but then you'd have 200 inches. It'd be kind of long. You'd probably want it to be something relatively small. A millimeter might be the best thing to use. So 200 units at an angle of 30 degrees counterclockwise from the x-axis. So I'm going to draw the x-axis as a vector that goes to the right from my origin, which is right here. The origin is where I will place the protractor, and I will note an angle of 30 degrees counterclockwise from the x-axis. That's exactly what this means. This angle here is counterclockwise from the x-axis. It's another way to measure angles. We're using east of west, or sorry, east of north, south of west, things like that. Here I'm just going to go counterclockwise from the x-axis. And I want it to go for 200 millimeters, which is 20 centimeters. So I'm going to set my ruler here. I'm going to connect my ruler to that point, and I'm going to draw a line that's 20 centimeters long, coming from the origin and stopping at that point, or stopping at a point 20 centimeters away from there. So that's my first vector. That's the very first one here, which I'll call vector A. That's this one. Now I want to draw vector B, but I want to start vector B from where vector A is, so that I'm actually adding them together. So from this point here, I'm going to draw another x-axis. All right, so I'm going to make sure it's level, parallel to the other one. So I have a little level here to do that. You could just draw a line that's parallel to the other one there. This is my x-axis for this point right there. Okay, so now I'm going to set up my protractor, and I'm going to draw from here an angle that is, as I say, 120 degrees counterclockwise from the x-axis. All right, so I have to go to 120 degrees. 90's up here. 120 is right there. And I want it to be 300 units, which is 30 centimeters long. All right. So I'm going to go here, draw a line that's 30 centimeters long from here. All right, 30 centimeters is all the way up there. And I'll draw a line from here to there, and that's my vector B. Excuse me. All right, vector A, vector B. Now I want to draw vector C. I almost need a step stool for this. Might get kind of interesting. I'll try to draw vector C from here, and then I'll draw a horizontal line here. It's going to get interesting, really interesting. I didn't plan this well. Okay, there's my x-axis from that point up there. And I want vector C to be at an angle of 235 degrees. Fortunately, that means it's going to start coming back down. So I'm going to go here, and I know that 180 is right here, so 235 is going to be somewhere over here. So to find it, I'm going to do it like this. 235 degrees is going to be in this quadrant over here. 235 is the same thing as 235 counterclockwise is going to be the same thing as 360 minus 235 clockwise, which, if I do the math right, is 125 degrees. So I believe I am going to be here. Let's see if that's right. 235, that's 180. 180 plus 55 would be this. So that is the location. So I want to actually be 235 degrees counterclockwise is the same thing as 125 degrees clockwise, because they have to add up to 360. That one has to be 35 centimeters long. Maybe this ruler will work better for that than my other ruler. So 350 units is 35 centimeters. So I'm going to connect from that point there through the point that I drew at the right angle. I'm going to go all the way down to 35 centimeters. Oh, that's inches. I need to go centimeters. Let's see if I can do that. Here we go. 35 centimeters is right there. All right. So that's my final point. That is vector C that I just drew right here. So here's what happened. Vector A is this. Vector B goes over to here. Vector C comes all the way down here. This angle, of course, is 30 degrees. This angle is the 120 degrees. And this angle here is 235 degrees. Okay, so that's how I graphically end up with that point there. Now what I'm interested in is the angle and the distance from here to there. So I can actually measure that with a ruler, then I can calculate it again with analytical techniques, which is like what we did in class and other videos. I'll do it again here. At least I'll set it up for you so you can see how I'll do that. Then we're going to compare them, and that's the point of this lab. All right, so I'm going to just darken this marker. I'll draw the resultant vector of adding those three together like this. So when I add this plus that, I get this vector right here. The red one. Okay, that's my resultant vector. Let me see how long it is. I see that it is, within the accuracy limit of my measurement, it's about 21 centimeters, which is about 210 units, based upon what we call a centimeter being 10 units or 10 millimeters. The angle, use my protractor to measure that angle. So this is the angle that I'm interested in. This angle from the original x-axis to that vector is this angle here. That's the angle I'm going to report for that vector in this case. That angle is, let's see, looks like around 155 degrees. If I go from here all the way over to there, looks like 155 degrees. 155 degrees counterclockwise. From x-axis. Now I know that that angle probably bothers some of you who are doing the homework and using the south of east and west of north and all that. I could write this, if I take that to be north, I could take 155 degrees counterclockwise from the x-axis. I could also subtract 90 from that and call it 65 degrees west of north. So that's also equal to 65 degrees west of north. If north was that angle there would be necessarily 65 degrees, because 65 plus 90 is 155. Similarly, I could also call that angle, if I don't like the 65 degrees west of north, I could say that it is, well, if that's 65, this one has to be 25 degrees. 25 degrees north of west. So those are all valid ways that I could express that angle that I found. Okay, so that's the graphical measurement of vectors. And I want you to do something, actually the same thing on a piece of paper that you'll submit with your lab. And you'll be able to use the protractor that comes with your lab. Talk more about that in another video. I wanted you to see the very top of the board. I realized that previous video just cut it off. So there's the whole board. Hopefully that'll clarify any questions you had.